And so in 15 minutes, it's not going to be 8 years. It's going to be about 4.5 minutes. Let me I'm going to dive right in really quickly. I can't cover it all. This is Suzanne Herder had asked if I would actually talk about a really short version of the SPE Distinguished Lecture that I gave over the last year, which was really to talk about all those things you see at the bottom. And I've picked a few, the highlights, maybe the most exciting pictures, and we'll talk about that. A few things about sort of background in CCS. I've been at this a long time, all the way from the days of Weyburn. Chaired the technical committee that developed the CSA standard for CO2 geological storage. A lot of work in Alberta and so on. Reviewed Gorgon and so on. Quest, been involved in Quest for quite a long time. One of the things of the context a little bit was what's happening in Alberta. Places a little bit in context is that um, there was quite a competition for pore space in Alberta. Those little blue regions that you see there are currently about 25 storage hubs under development, under appraisal, full appraisal, trying to go through the creativity and innovation of MMV plans by spending $5 or as little money as they can. Um, and it's a challenge. So much of the stuff that was talked about over essentially, I guess, the last 3 days for sure, and even this morning, is that right at the heart of developing these storage hubs. Aquistore has been around for quite a long time. It's down in the southeastern corner of Saskatchewan, but it and Quest, in a way, have actually formed um, sort of base set of knowledge, if you like, for most of the people trying to develop those storage hubs in Alberta. So consultants who have now become CCS experts overnight have gone to that data and are really trying to build up their expertise. And so this is a historical performance becomes important when you look at that context. I should say the part that's interesting in Alberta, maybe in the EU context a little bit, is those blue regions are all CCS hubs, but it's actually about hydrogen. This is actually all about supporting the hydrogen economy development in Alberta. They want to be able to have the ability for very massive investments in hydrogen production to be able to manage their carbon. So let me get right at Aquistore. Again, we only have you for 15 minutes, and I want to show you the exciting data. And so SAS Power, one of the first power plants that put capture and storage supplies of CO2 to EOR primarily as a way to monetize the CO2. One thing I will say in the second bullet point is a reminder is that the Aquistore project was designed a long time ago, not 2023, not with the kind of ISO standards we live with today. It attempted to try and design full-scale injection projects, designed for the wells and so on back in 2010, 2011. So essentially, the bottom line is that there'd be stuff in Aquistore we've learned you would not do today. None of you guys would execute a project today. There's some things you just would not do. Um, so the rates are relatively modest, 400 tons per day. But the one thing about Aquistore, which was extremely valuable, we always knew it would be extremely valuable, is just dynamic injection. We could not control it. It's not a science project anymore. SAS Power supplies CO2 when and where and how much they want. It goes up and down. I'll show you some pictures in a minute. It was really dynamic. So this whole question about intermittency, you'll see some of the results in some of the slides. And so a modest amount, 600,000 tons as of February. I'm not going to talk about this. Lots of MMV, everybody has been talking about it. But I will say that the one thing that might be valuable for people working this area is that little link that's in the side. I think the slides get published and you can have it. Is a part of a guidance to those 25 storage hub projects. The Alberta government crew did stuff, sort of helped a little bit with it, but they developed this thing with guidelines, principles. And in much like in the conversation this morning, they're all performance based. They're not prescriptive. They're all just performance based, and you can go and it's a worthwhile document to go and have a look at. Site configuration for yeah, okay. So let me a little tough from the back, but site. So there's the boundary dam. The boundary dam 3 comes off into the amine capture. Comes off in the pipeline, goes off in the pipeline, comes all the way over here to EOR. There's a small pipeline segment comes on here, and it's nothing fancy. A site visit would not, it's not all that fancy. Comes into a metering building, comes in and through a gate valve here into the wellhead and injected. I'll show you some pictures. That's just what the land looks like. Um, And that's kind of what it looks like in the daylight. Injection well, 150 meters away is an observation well. There were these monitoring stations here. Chat about that in another time. Um, this is a building that was Dogmec from Japan is testing their across source here, which is a permanent, very, very fancy offsetting washing machine. Very, very, very complex bunker that can sweep frequencies, and you can run seismic surveys at any time. And the last run, which I'm not going to talk about today, fiber was buried in the surface here with some of the new fiber, and sort of the fifth time-lapse seismic and the across did a fifth time-lapse survey, and it apparently worked well. So we'll see the results soon. So the subsurface setting, for those who haven't seen Aquistore, really quickly, just so you can put the data in context, we're sitting here in this Deadwood Formation, basal Cambrian sandstone type formation here above the Precambrian. Everybody, we have to define a storage complex. Our storage complex essentially is the injection into this Deadwood and a little bit of this Black Island sandstone. But much like in Alberta, in Quest, we're benefiting from a salt, very thick salt prairie evaporite as an ultimate seal in the storage complex. So really quickly in the ejection horizon, this is what you'll see in the video, which is a part of the challenge. There was interpretations of the geology on at the well, the ELAN log, and interpreted that there were these packages of sand likely. So perforations were these gray. So try and remember these a little bit. 1, 2, 3, and 4. And the reason to want to memorize that is that this perforation too, this little thin zone in here is actually taking probably 60 to 70% of the CO2. Ran out of money, so unlike a lot of projects, couldn't take core all the way through. That's a long story, and we'll have to do that at coffee some other time. So a couple conditions of the reservoir to share with you relative to experience. It's modestly pressured, 35 MPa, but it's very warm, 115, 118 degrees C. And in fact, it was once these wells were drilled and confirmed that this temperature down here was 118. It actually was the precursor for a geothermal project 25 kilometers to the west. It's called Deep. The other thing that's unique about this place is it's very saline, 330 grams per liter. So hyper saline. So these are a couple of the things that you probably would likely not do. But this was the well design, pretty conventional for what I think most people would see in an onshore these days. Let me highlight a few because the text is pretty small, but 7 5/8-inch casing. The other thing that was unique at this time was that, in fact, I saw a diagram, I think yesterday, completion diagram was using Chrome 25. And at the time here, the only thing you could buy was Chrome 11. And so even then in 2011 to secure the Chrome, we couldn't even buy very much. So the only configuration we had for Chrome was just this small portion across the backer. And it essentially comes back to even L80 conventional steel down here. But because of a bunch of other issues, we can't get down here yet because of the way the packer won't move. That was the question yesterday asked about elastomeric seals. The packer in this well is only coming out with a drill bit. But it's going to be interesting to test the conditions of this casing at depth. So it's L80, right inside CO2 saturated brines. And then it transitions up to regular casing uphole, CO2 resistant cements, a production packer, CO2 resistant cement above the thing. Well, the other thing that's here is that this is regular L80 tubing. It's premium connections, but L80 tubing, so there's no special, there's not lined, it's not chromium. The expectation is you're injecting dry CO2, so operationally you should be good to go. Didn't quite work that way. The other thing about gauges, if you're making decisions, has had a little bit of a researchy element to it. We tried to run pressure and temperature gauges on the outside of the casing. You would probably not do this today. In fact, I would recommend you don't. But it did have fiber optics strapped to the tubing string, and I'll show you some of that data, and a downhole pressure gauge, the tubing into the packer, a DTS line. In this particular case, there was an attempt to run the DAS cable, DAS and DTS on the outside here, but it failed up there. But there is a line fiber that's been used for DAS and DTS on the backside of the casing in the observation well, that pink line. Let me just switch to that really quickly. This is another thing I would suggest, that if you are going to install observation wells, um, be very mindful of the fact that if wherever this observation well, if it sits inside this plume, um, I don't know why we made this decision. I've been looking for a long time to why we made this decision. But this is L80 casing all inside where the CO2 plume is in the obs well. And so it's been sitting inside the CO2 plume for 7 or 8 years. I think if you design obs wells, you got to be very careful about this. And there were some other things that were done here: CO2 resistant cements, the fiber four casing conveyed gauges, again, when that, but a specialized fluid recovery system that's now been turned into something called thinking about value of information. I would say one of the learnings from Aquistore so far has been the conversion of this to what's called a bubble tube. I got to tell you, you cannot have more value for information than put in a bubble tube, and it's phenomenal. And I can explain it later. I just only have 15 minutes, so I'm going to show you the data. But incredible. Costs you $5, it costs you $5, and you get $1 million worth of data. So this is the dynamics, and I'll show you a few more. And again, this is just the response of the fiber strapped to tubing in the injection well and in the observation well. The blue up here, you can see the injection profiles, the injecting, shut in, so on. This is just early on, 2016, 2017. People have seen this in other, I mean, today you do this in oil and gas and stuff, but in this application for CO2, there's a very rapid temperature profile changes, extremely rapid actually. And so that's actually part of the challenge, especially when it comes to well integrity. For conditions of injection, when you're thinking about multi-phase, we're liquid phase at the wellhead and dense phase down here. This is again in the social acceptance word. You're not supposed to say the word supercritical anymore. Right? Dense phase CO2. So we move from liquid phase to dense phase, and it's actually some interesting. I'll show you some data, and you can tell me if you can explain some really interesting results in the shut-in response for this. So this is the dynamics. So I would suggest that you not start up your wells this way. I think most people have programs now. When they look at it, they don't start wells this way. I've taken the well integrity. My apologies. I've taken the well integrity results out because I only had 15 minutes, but there's data in behind that's suggesting that these kinds of cycles and the temperature and pressures that you see in behind the casing on the casing conveyed gauges way above the perforation intervals, yeah, it does not survive. It will not survive these conditions. The other thing that happens for us is, and I think it's been shown before, is that when you capture this DTS data during injection, which is orange, blue is shut in, is that under injection, this phase is less dense than this phase. And what happens then in shut in, you actually get these reversals and refluxing that happens in the wellbore as phase changes and heat is changing and enthalpy content is, anyway, it's quite complex. The other thing that we noted from the data in Aquistore is that it's 330 grams per liter. You look in the literature, we got salt, everybody, salt precipitation, we're going to get damage. We actually went up an order of magnitude in injectivity. We didn't go down. And so when we cooled from 118 degrees C to 65, we actually went up an order of magnitude. And again, I haven't really shown it here. That's actually all due to thermal induced fracturing. Thermal induced fracturing in the near-bore wellbore region has just absolutely swamped anything to do with salt precipitation in near wellbore. That does not mean it's not going to go away in the long term in Aquistore. It's only 600,000 tons, but there's some early performance data that's really instructive. So here's some interesting results of monitoring. There's about some field case histories, and I'll show you an interesting response that we haven't quite figured out yet. So this is 2021. I apologize, I haven't switched the colors. This blue line at the top is temperature. The blue line in the middle here is bottom hole pressure, and this is the injection rates. And so you're injecting along at a period of time. There's a shut in for a period of time here till middle of July. And if you look at this response in the middle, you get what I think you don't even, natural response. You shut in the well, the bottom hole temperature rises, the bottom hole pressure falls off. But what you can see is that I inject for a little while here at the end of July, and then look what happens when I shut in. I'm shutting in, the temperature rises again, but look what happens to bottom hole pressure. Cycles like that. So yeah, see, 15 minutes. I got to show you those. So this is shut-in behavior. So this is important to show. So I've shut in the well, and you would expect this to fall off, but look at what happened on these spikes. is during shut-in. I take another time, 2022, it's the same thing. I've shut the well in, all of a sudden I come down and I get these spikes. And so this is an issue of a completely shut-in response in the well bore, and all of a sudden I'm getting these spikes in the pressure response up the tubing string. It shows up in the DTS data. So here's the spike, it falls off, and I get this rapid cooling response, and then warms up, and I get this drop and thing. So very complex phase behavior responses. Erosion is an issue. I need to show the video now that Jasper's standing up. The other issue about the learnings for this is completions and salt, is that there was a camera run in here, 4 months it was shut in, and just before there was any injection, what you're going to see is the perforation interval that did not take CO2. And it should look like outer space here in a second. So after 4 months, over that perforation 3, this is the state of precipitation in the wellbore. At one point, you'll see a side camera view in the middle. The crystals come shooting out, poke you in the eyeball, right out of the perforations. And again, you can see the rivers of precipitation. You'll see pink show up on the left-hand side here in a second. This is pure halite. Camera is banging its way through this thing, trying to get to depth. And so this is extremely instructive. The question is that, what does this mean for well integrity? What does this mean for kinetics inside the reservoir? The other part that's interesting is this is the image you saw on the left. In 2020, that's what exactly the same interval looks like. So there are operations that are happening in the wellbore that, in fact, the precipitation, and I think I've taken it out, is that the precipitation, you say, oh, whoa, look, 2020 went away. Yeah, no, it did not go away. It fell into the sump. And so all of the thing, it is now filled up all the way over per 4. And unlike Quest, we can't do a hot water flush. They're only at 60 degrees C. They circulate some hot water and life is good. Can't do that. So we're trying to figure out how to get at this and clean it. The other issue, and this is going to be the last one, Jasper, because it speaks to even the comment this morning, was there were some issues about interpreting the geological model. It turns out we had a basement flexure. We don't use the other F word in Aquistore. We use flexure. This clearly, these pink lines, these dotted lines, just really quickly for everybody, these dotted lines have been the interpreted outline of the CO2 plume after 4 time-lapse surveys. And what you can see is the injection well is here. What you can see is that the plume has barely moved to the southwest. And so there's something that's impeding the movement of the CO2 plume to the southwest, and it's elongating kind of in the direction of the flexure that we have to deal with. So now the question is, and then I'm going to think this is a question for MMV and the question we talked about today with regulators. So I'm a storage hub person and I'm trying to do this and I'm trying to analyze this data and I'm worried about conformance and I have to submit a report to the regulator. And so I spend all of this time. The only way we could get to this as a prediction is we had to do full geostatistical realizations, deal with the flexure, and do a full AVO inversion on the seismic to condition the distribution of properties. And we then barely kind of got to some simulation result that predicted the outline of the plume. Yeah, a regulator didn't care. So we're doing the projects. You have annual requirements to update the model. This is the only model that is actually sent to the regulator. The only model that is sent to the regulator is a simple layer cake model that was built in 2011 that is updated. The properties on average are updated from the bottom hole pressure data, the injection historical data. And this is updated and that's what the plume looks like and is submitted to the regulator and they've checked the box. So one of the last things, oh, I guess I lied, that's Jasper, sorry, is one of the things to try and extract more data out of this was, today, a lot of where the expertise in the room sits are these 2024 advanced workflows. All across we've heard about them all. There's huge, doesn't matter what, log-based, seismic-based, whatever, it doesn't matter. We're going to try and take these and actually come all the way back to 2010, 2011 in Aquistore and say, okay, we've got all these fancy tools. What if we came all the way back here and I only gave you the well 25 kilometers away, 30 kilometers away, and 40 kilometers away, and said, okay, now you build me the geological model using all the fancy advanced workflows, build a reservoir model based on that, and forward predict exactly this behavior, and you tell me how well you do. And man, I hope we do not do well, or we are going to be out of work, right? I'm going to assume we won't do well. Let's just say. Then the next step is I'm going to give you the baseline 3D seismic survey, update the model, do the simulation, tell me how much you improved it in 2023. And I'll give you the injection well data, future physical data, core data, whatever you want. Rebuild the model, redo the simulations, tell me how, and find out where do we actually buy down the uncertainty? When does it matter? My guess, we are not going to make a significant dent on buying down the uncertainty until you have a year's worth of injected data. That's my guess. You could shoot 400 3D seismic surveys and it isn't going to matter. That's my guess. Thank you, Josh. All right, better stop.